Welcome to the DIY Honda Garage channel. DTC P0404 indicates an EGR circuit range or performance problem in the Honda Accord models from 2008 to 2012. The EGR, or exhaust gas recirculation system, plays a crucial role in reducing nitrogen oxide emissions by recirculating a portion of the exhaust gas back into the intake manifold. This process helps in improving fuel efficiency and reducing harmful emissions. When there is a range or performance issue with the EGR circuit, it can lead to poor engine performance, increased emissions, and even engine damage. It's important to address this issue promptly to maintain the vehicle's overall performance and compliance with emission standards. This guide provides a comprehensive step-by-step approach for diagnosing and repairing the EGR system, ensuring that all necessary checks and balances are adhered to for effective troubleshooting. The EGR valve is a critical component in regulating the level of exhaust gases that are recycled back into the engine intake. Its placement is typically in the engine bay, making it accessible for inspection and maintenance. A malfunctioning EGR valve can lead to incorrect readings and eventual triggering of the DTC P0404. The valve's role is to prevent excessive nitrogen oxides emitted during combustion by recirculating exhaust gases. If the EGR circuit does not produce the expected range of performance, the vehicle will enter a fail-safe mode to protect the engine. This issue not only impacts emissions, but can also hinder engine efficiency, leading to more extensive maintenance needs over time if left unresolved. Several factors can contribute to the triggering of DTC P0404. A common cause is a faulty EGR valve, which may become stuck or fail due to age or manufacturing defects. Wiring issues, such as frayed or broken wires leading to or from the EGR valve, can cause communication problems within the circuit. Furthermore, carbon buildup in the EGR system can obstruct flow and degrade performance, which is particularly common in older vehicles or those with inconsistent maintenance. Each of these potential causes can create symptoms that may affect engine performance or emissions, emphasizing the need for a thorough diagnostic approach to pinpoint the exact issue. Symptoms associated with DTC P0404 may vary, but typically include poor engine performance. The engine may hesitate or stall, leading to a decrease in power when accelerating. Additionally, an increase in emissions can be detected, which may trigger an emissions test failure if not addressed. More commonly, drivers will notice a check engine light activating on the dashboard, which serves as the vehicle's first warning system. If these symptoms occur, it's essential to act swiftly, as prolonged neglect of the EGR system may lead to more costly repairs down the road and suboptimal vehicle operation. The first step in troubleshooting DTC P0404 involves turning the ignition switch to the on second position without starting the engine. This step is crucial as it powers up the vehicle's electrical systems, including the onboard diagnostic systems. Activating the ignition allows for necessary checks to be made through the vehicle's diagnostic tool, such as the Honda Diagnostic System, HDS. This procedure is fundamental in preparing the vehicle for subsequent diagnostic steps, ensuring that the systems are in an operational state. It's important not to start the engine yet, as the initial troubleshooting steps focus on preparing the systems for diagnostic testing. Following the initial ignition step, the next action is to clear the DTC using the Honda Diagnostic System, HDS. This process involves accessing the diagnostic menu and selecting the option to clear all stored trouble codes. Clearing the DTC is an essential step because it resets the vehicle's fault monitoring systems. Once the codes are cleared, any new faults can be logged and assessed without interference from historical DTCs. Clearing the codes also helps identify if the P0404 issue is persistent or just an intermittent fault. The goal here is to create a fresh state for the diagnostic process ahead. After clearing the DTC, the next step is to start the engine and hold it at 3,000 RPM without load. This means that the automatic transmission must be in park or neutral, and the manual transmission in neutral to ensure that no additional load is placed on the engine. Holding the engine at this speed is critical for the diagnostic process. At this RPM, the exhaust and intake systems are under conditions that can trigger the EGR system to operate as intended. By allowing the engine to run at this speed until the radiator fan activates, technicians can fully engage the system for proper testing. After the fan comes on, it's important to let the engine idle to return it to a low-speed state for subsequent evaluations. With the engine idling after the RPM test, the next action is to conduct an EGR test through the Honda Diagnostic System, HDS. This evaluation is part of the inspection menu and is designed to check the operational status of the EGR system under current engine conditions. The HDS will prompt various tests to measure both the performance and the functionality of the EGR system. Depending on the results of the test, it will either confirm that the system is functioning correctly or indicate a fault that requires further investigation. If the results show that the system is okay, it indicates an intermittent failure, prompting maintenance actions like cleaning the EGR valve for carbon buildup. Conversely, if the results are unfavorable, additional diagnostic steps will follow in the troubleshooting process. In this step, the technician is instructed to turn the ignition switch to the lock 0 position to ensure that the vehicle's electrical systems are completely powered down. Shutting off the ignition is critical to safely proceed with physical inspections and disconnections without risking any electrical shorts or inadvertent activations of components. This step is essential for safety and avoids potential damage to sensitive electronic components. Once the systems are powered down, technicians can access the EGR valve for the upcoming diagnostic checks, establishing a safe working environment before diving deeper into the troubleshooting process. After shutting off the ignition, the next step is to disconnect the EGR valve's 5P connector. This physical disconnection allows for critical electrical measurements to be taken at the EGR valve itself without any interference from the vehicle's circuits. The EGR valve 5P connector is vital for both signaling and power supply to the valve, and its removal is necessary for subsequent testing procedures. Technicians must ensure that they handle the connectors with care to avoid any potential damage, as faulty connectors can be a source of issues in the EGR system. This step is crucial for the integrity of the testing process that will follow. With the EGR valve connector disconnected, the next task involves measuring the resistance between specific terminals of the EGR valve's 5P connector. The technician should focus on terminals number 2 and number 3 and use a multimeter set to the resistance setting to obtain a measurement. This process is critical in assessing whether the EGR valve is functioning correctly. A resistance of 100 kiloohms or more would indicate that the circuit is intact. If the reading falls below this threshold, it presents a fault condition that necessitates further testing. This measurement provides significant insights into the health of the EGR valve, allowing technicians to diagnose potential electrical issues that may be affecting performance. Following the initial resistance measurement, the next step involves checking the resistance between terminals number 2 and number 4 on the EGR valve's 5P connector. Similar to the previous measurement, this step helps to identify whether the circuit is functioning within the specified range. A reading of 100 kiloohms or more indicates that the wiring and the connector are likely in good condition. suggesting that the circuit can communicate effectively. If the resistance is below this value, it indicates a problem that must be addressed with wiring or the valve itself. This process helps to isolate issues within the EGR valve circuit and directs the technician on how to proceed with repairs or replacement. In this penultimate step, the technician checks for continuity between EGR valve 5P connector terminal number 5 and the vehicle's body ground. This step is vital to ensure that the EGR valve has a solid ground connection, allowing for proper operation. Using the multimeter, the technician will measure for continuity, which should yield a low resistance reading, indicating that the ground connection is solid. If there is no continuity or high resistance, this suggests a grounding issue that can lead to erratic EGR valve performance. Repairing or establishing a proper ground is crucial for the system's overall function and should be prioritized before proceeding further. This final continuity check is indispensable for confirming the integrity of the EGR valve's electrical circuit. After completing all the troubleshooting steps, the final repair verification process begins. This involves taking the vehicle for a test drive under various conditions to ensure that any repairs or adjustments made to the EGR system are functioning correctly. During this drive, monitor for any recurrence of the DTC as well as overall engine performance, such as smoothness of acceleration and idle. Any signs of abnormal behavior or illumination of the check engine light would warrant further investigation. It is critical to confirm that all systems are operating as expected to prevent the issue from resurfacing. Post-repair verification provides peace of mind that the repairs addressed the root cause of the DTC and that the vehicle is now fully operational and compliant with the mission standards. To prevent future occurrences of DTC P0404, implementing a preventive maintenance plan is beneficial. Regularly cleaning the EGR valve can help prevent carbon buildup, which is a common cause of performance issues in the system. Scheduled inspections of the EGR system and associated wiring connections are essential to catch any deterioration before it leads to failure. Keeping these components in optimal condition not only extends the lifespan of the EGR system, but also optimizes engine performance and efficiency. Following manufacturer-recommended maintenance schedules will help ensure that the vehicle operates smoothly and complies with emissions regulations over time. Early intervention is key to preventing more significant issues that may arise from neglect. In conclusion, understanding the EGR function is crucial in tackling DTC P0404 effectively. The steps outlined in this troubleshooting guide provide a systematic approach to diagnosing and repairing EGR-related issues. By meticulously following each troubleshooting stage, technicians can accurately identify faults within the EGR circuit and resolve them effectively. Additionally, establishing a routine maintenance schedule reinforces the EGR's performance and ultimately enhances vehicle longevity and emissions compliance. Awareness of this process not only aids in facilitating repairs, but also in fostering a proactive approach to vehicle maintenance for Honda Accord owners. Maintaining vigilance with these steps can ensure the vehicle remains in peak condition and runs efficiently for years to come. Please like and subscribe to the channel. See you next time.